a ball is thrown vertically upward with an initial velocity of 30 meters per second. What is the maximum height reached by this ball? And in this problem, we are taking the acceleration due to gravity to be 10 meters per second squared, and of course, neglect the effect of air resistance. This is a problem on kinematics, and in kinematics, we describe the motion of an object without any reference to forces. So we describe the motion in terms of position, displacement, velocity, and acceleration in time. So what happens when you throw a ball vertically upwards? What happens is that with the throw, you give the ball an initial velocity, which is v0. And this ball or object is going to be displaced from that initial position vertically upwards until it reaches a maximum height. So with the initial velocity, as the ball travels that vertical height, it slows down until it reaches that maximum height, which we can call h max. And at this maximum height, it is going to have some final velocity, v final, which is equal to 0. Why? Because anytime you throw an object vertically upwards, it goes up and then momentarily stops and then returns back. So at the point where it stops, the final velocity is 0. Now, we have 4 equations of motion we can use to solve this problem. But we need to be very careful because some of the equations wouldn't be able to help us in solving this particular problem. Why? Because in this problem, we have the final velocity is equal to 0. We know the initial velocity is 30 meters per second. We don't know the final maximum height, so let's call it delta y. That is the vertical displacement, which is what we are looking for. And also, we know acceleration due to gravity, we are given to be 10 meters per second squared. Now, we are not given any information about the time it took this ball to get to the maximum height, so we need to use that as a guidance to help us to rule out any equation that has time. Else we are going to double the trouble. All right, but the only equation that we can use is the velocity as a function of displacement equation, which is given to us as v final squared is equal to the initial velocity squared and then plus 2g and then delta y. And delta y here is the vertical displacement. Okay, so that is the change in the vertical position of this ball. If we are looking for delta y, now we need to isolate it. Step by step, we can move this v0 squared to cross the equal sign. So the equation becomes v final squared minus v initial squared is equal to 2g delta y. So with this, we can isolate delta y by dividing both sides of this equation by 2g. So this 2g cancels this to 1. And then in that case, we have delta y to be equal to v final squared minus v initial squared divided by 2g. So let's plug in our values and then determine the final value of delta y. So delta y is going to be v final squared, which is 0 squared. That is the speed of this or the velocity at the maximum height. Okay, so 0 squared and then minus, all right, v initial squared. So we have 30 squared and then divided by 2g. So we have 2 times g, which is 10 meters per second squared, but g is pointing downwards. So downward is negative, upward is positive. So minus 10 meters per second squared. And then if you simplify this, you can take your time and do the calculation. This is going to give us negative 900 divided by negative 20. So this will give us negative 900 divided by negative 20. And that is going to give us positive 45. And the unit for displacement is the meters. And this gives us the displacement or the maximum height reached by this ball when it is thrown vertically upwards with some initial velocity, which is v0. The physics we can learn from this also is that the height or how high the object goes depends on the initial toss velocity. All right. If you like this, give us a thumbs up, share, and also follow us. Until then, I'll see you in the next one. Bye-bye.